Hello and welcome back, and this week's video is going to be all about the product rule, which is used for derivatives. And more specifically, we'll be looking at what it is, how to use it. Well, let's start off with what the product rule is and what it's used for. What do we need the product rule for? Well, the product rule, like the name suggests, is used when your function, in this case y, is made up of two functions that are getting multiplied by each other, in this case f of x times g of x. So if, for example, h of x is equals to f of x times g of x, then to take the derivative of h of x, we have to use the product rule, because we simply cannot apply our other rules because we have these two functions that are getting multiplied by each other. So let's take a look at what this product rule is. The product rule claims that if you have a function that is made up of two functions that are multiplied by each other, so let's refer to these two functions that are getting multiplied by each other as f of x and g of x. Well, then the product rule claims that your derivative of y is going to be f prime of x, so the derivative of one of those functions, times g of x, so the actual other function itself, plus g prime of x, so the derivative of the other function, times f of x, so the actual function that you took of the derivative previously right here. So, for example, if we had a function that, let's say, h of x is equal to e of x times ln x, then what we could do is we say this is f of x, e of x is f of x, and g of x is ln of x. So what we could do is we take f prime of x, so dy dx of e of x, times ln x, simply by itself, plus g prime of x, which is dy dx of ln of x, times e of x, simply by itself. So this is the basics of the product rule, and refer back to this always when in doubt. It's pretty simple, as you can tell. It's only multiplying and adding. And now let's look at a couple of examples to really enforce this idea in our understanding. So let's look at example number 1, where we have y is equals to, in brackets, 3x cubed plus 4x squared, all of that times 2x minus 5. So first, let's recognize that this can be, for example, our f of x, and this can be our g of x. So y prime, or the derivative of y, is going to be firstly the derivative of f of x, so in this case dy dx of 3x cubed plus 4x squared times g of x times the other function, so 2x minus 5, and then plus, we're going to take the derivative of the second part of the function and just multiply it by the first part without taking its derivative. So what is the derivative of 3x cubed plus 4x squared? Well, we simply take the power rule and write that as this times 2x minus 5, and then here the derivative of this part right here is simply 2 and then times 3x cubed plus 4x squared. And this is pretty much as simple as it is. That's all there is to it. Now you could go and simplify this, so we would get, if we expand it, we would get 18x cubed minus 45x squared plus 16x squared minus 40x plus 6x cubed plus 8x squared, and then we collect the like terms to get our final answer, which is going to be 24x cubed minus 21x squared minus 40x. Now this is obviously not the important part. The important part is knowing how to use the product rule when you see a function that looks something like this, but just for the sake of really taking the example to the end, we're going to simplify it. Okay, let's move on to the second example. We have here ln x times 5x squared plus 6x minus 1. And again, we can recognize that this function, y, is made up of two functions that are getting multiplied by each other, where, for example, f of x is ln of x, and g of x is going to be 5x squared plus 6x minus 1. So again, how do we deal with this? Well, we take first the derivative of ln x, and then we multiply this simply by 5x squared plus 6x minus 1 without taking the derivative. And then we switch this around and we take the derivative of the 5x squared plus 6x minus 1 and simply multiply it by ln x. So the derivative of ln x is 1 over x, and that's totally okay if you're not familiar with that because this is not the point of the video, but we're going to have 1 over x times 5x squared plus 6x minus 1. Again, just make sure that you understand how the product rule is getting applied in this case. You don't really have to understand all the little details in the calculations that come afterwards. And then the derivative of 5x squared plus 6x minus 1 is 10x plus 6 times ln x. So if we simplify this, we're going to get 5x plus 6 minus 1 over x plus 10x ln x plus 6 ln x. And this right here is our final derivative. Right, so let's move on to the last and final example to solidify this in our understanding. So here we have y is equals to 3x times e to the power of x. And again, we can see that this y is made up of two functions that are getting multiplied by each other, 3x and e to the power of x. So in order to take the derivative of y, we're going to first take the derivative of 3x, simply multiply it by e of x, and then we're going to take the derivative of e of x and simply multiply it by 3x. So the derivative of 3 of x is simply 3, so 3ex, e to the power of x, and then the derivative of e to the power of x is simply e to the power of x, so we're going to have 3x times e to the power of x, and this right here is going to be our final derivative. So I hope that these examples really showed you how you apply the product rule. Again, just recognize that if you have two functions that are getting multiplied by each other to make up your main function, such as y right here, then you always apply the product rule. Of course, in cases like these, you could multiply and factorize. Sometimes that is simpler and easier, but sometimes the product rule really comes in handy. So I hope you gained a better understanding of the product rule and how to use it, when to use it, and how you can apply it to actual concrete examples. And if you're interested in seeing the proof of it, I would gladly do a video on that, so just comment down below, because I really think that a proof further solidifies your understanding and really makes you understand where this rule comes from, so why you're using it. So I hope you enjoyed, and see you next week.